Number 1, what do we do? Factored it. X, 1 plus x, parentheses squared. Square root of x, 1 plus x. Now, you may wonder why they said from 1 to 5 only. Well, you have the whole square thing happening. Well, from 1 to 5, 1 plus x is always positive. So it's a safe boundary to not get anything that you would have to worry about squaring out a negative and then changing it back. So they made it easy on us. 1 plus change it squared is secant squared, so the square root is just secant. What's differentiable mean? Able to find the derivative at those points. When can you not find derivatives? Sharp corners. Cusps. Okay, so an undefined derivative in general, and all which would be like a vertical tangent line. So discontinuities. So sharp corner, where at? Yeah, I don't need to do any work to see that. The second one, I need to do a little work to see what's going on. F prime of x is 2/3 times 5, which is 2/3. X to the negative 1/3. Why is that a problem? X to the negative 1/3 is on the bottom, and so at 0, that would not be differentiable because we would have 0 on the bottom. Any questions on those? Today, you're going to learn how to find the length of an arc on a curve. So the length around a curve. Now we know how to do it if it's a circle. We know how to do it if it's a rectangle or a square or something like that. But we want to be able to find the length on any curve. Well, as you can imagine with calculus, we make things small enough, right? Because you see a pattern with this. If we make things small enough, couldn't we look at this as just a bunch of little lines along there? Yeah. Yeah. You wanted to.
You have to really
like infinitesimally small, like differential small, like calculus small, right? If we did that, we could find the length. We got small enough, we'd be exact, right? Well, would you agree that this length is the square root of x, change in x squared plus the change in y squared? Pythagorean theorem. We want to add a bunch of those teeny tiny lengths up. That does involve a differential. So we had to kind of rewrite it to get an integral. So we need the delta x on the outside, for an integral. To make that happen, we can multiply and divide by anything we want. Would you agree? As long as we do it at the top and bottom. So what they did is they took that formula for the distance and multiplied and divided it by delta x. So it's a k. To get that in under the radical with the other things, you have to square it. Like square of the square root would kind of be the same thing. And so those would cancel. You just get 1 over delta y divided by delta x squared. What's delta y over delta x? Change in y over change in x. It sounds like something I've heard of before. A slope or a derivative, right? You can imagine we could have done the same thing except dividing and multiplying by delta y if we had 1 and 2. So that brings up a formula that gives us the length of a curve. This you need to memorize. In fact, you probably already have memorized it. Why? It was on the gateway. Mainly, now I'm going to show you a couple of complex problems today. One complex one. And if you read your textbook, they do a lot of complex problems with these. All the AP problems, mainly, if you know this formula, you're good to go. So, that's good. So we have a smooth curve. What's another word for a smooth curve? And I prefer it to that. This is your textbook definition. I really don't like it. Yes, differentiable, continuous and differentiable. So we have a continuous and differentiable function. Why do you think it has to be differentiable? Look at the formula. You have to use the derivative. If I don't have a derivative, I'm in trouble. So you see why we talked a little bit about differentiability on the bell ringer. We have to have a differentiable function before we can use this formula. Then the length of the arc of the curve is given by the integral from a to b of 1 plus f prime of x squared dx. If for some reason it was complicated in an integral in x, you could see how we could do this with dy instead. The formula is almost identical, except it's the derivative of x with respect to y instead of the derivative of y with respect to x. So if you had the function in terms of x, x equals y squared, you could work it with y's if you wanted to. I haven't seen very many AP problems where they had you do that. Just mental note for Cal 2-3 purposes that you could work it. And there's a couple book problems I have you do that have some dy's in them, but I have not seen an AP problem with that. Any questions so far? So, find the exact length of the curve from 0 to 1. It does say exact. What does that mean in math class? Nope. Let's do it without a calculator. I picked this one because I wanted to practice some integration. So, what am I going to need to be able to do arc length or the curve or the derivative? I'm going to do that really quick. dy over dx or y prime is 2 radical 2 x to the 1/2. Is that right? I don't know where the x came from. 2 radical 2 x to the 1/2 power. Is that right? Yes. So I have the integral of the square root 1 plus the derivative squared, which is 2 square root of 2x to the 1/2 dx from 0 to 1. So simplify any under there. It does, I agree. Good. Square everything. 2 squared is 4. Square root of 2 squared is 2. 4 times 2 is 8. X to the 1/2 squared. What is x to the 1/2 squared? And I did tell you to do it by hand. I could integrate something that looks like that. Use substitution. What would my limits be? substitution on a definite integral, make sure you change the limits as well, or leave them blank. Again, don't write them and then, or leave them blank, substitute the x's back in. You can do that. Just be careful. AP really gets their panties in a lot when you do 0, 1 right there. They don't like that. So, okay, so u to the 3 fifths times 2/3, so 2/24 or 1/12. Right? I'll check my work. Plug in the 9. Square root of 9 is 3. 3 cubed is 27. 112 times 27 minus 112. Just 112. 1 to the power is 1. Yeah. Are you wondering about the 2/24?
No, I'm wondering about the 1/2.
I added 1 to the power. It was a square root.
It was a square root.
So I rewrote it as a 1/2 power for my.
So the way you got the 27 was you plugged it back in with the u. Or did you plug the u back in?
I plugged a 9 in for you.
How come you want to have to put the u back in?
Yeah.
Because I changed it.
To use.
Okay.
Oh, okay.
So I can take care of all of that. Now, if you left it blank, and then put the u back in, and then you can go from 0 to 1.
Okay.
You kind of did it all in one step, though, because when you found 1 and 9, you plugged 0 and 1 into here, and then you're plugging it in. So it works both ways. And you are welcome to leave it blank. Like I said, just be careful. Don't write 0 to 1 with the u there. AP really doesn't like that. Don't say no, that's not equal. 26/12 or 13/6. So got to do integral practice. Any questions about that one? Essentially, this is the arc length. You'll see a lot of the problems on the AP exam are setup problems. Remember how they would have you set up volume or set up area. A lot of the problems are even just setup problems on arc length. I did want you to see one tricky one. The likelihood that you would see this on AP, I doubt it, but just again, probably beyond AP BC calculus onto your higher level thoughts. So this is probably slightly unnecessarily difficult, but yeah, that's okay. Other than that, we okay with the formula? How that works? Which kind of gave you a hint by the title of the slide. What's the problem with this one?
You can't differentiate it.
It's not differentiable from -8 to 8. You remember I said to use the arc length formula, it has to be differentiable. However, if you look at a picture of x to the 1/3 power, it's a cube root x. Should you be able to find a link to that somehow? Finite curve. Seems like I should be able to.
You just separate it.
I could. You're still going to have a problem at 0, though.
When you just move over the thing that we've been.
want to know if it works, let me know. What else could I do? Perfect. Could I work it as a dy? Remember I said the formula works dy or dx. What's the function if I look at dy? Y cubed. Does y cubed have any problems? No. It's differentiable. So you could, if it's easier, if it's nicer, it's possible, you could use a function in terms of y just like you could with area, just like you could with volume. There is a formula, which y'all have it, for arc length in terms of y. So what do I need? I need the derivative. Now, what kind of derivative do I need? Read the formula. Dx over dy. What does that even mean? It means pretend the y is an x and take the derivative. I mean, for the most part, right? If you remember back to related rates, we could put a dy over dy there, but what's the derivative of y with respect to y? 1, so we're good. So nothing terribly complicated there. And so my integral would be the square root. What's the formula? Did you ask a question?
No.
1 plus the derivative squared. Now in this case it's dx over dy instead of dy over dx. You saw why in the when I showed you where the formula came from. It would be because you were dividing by the delta y instead of by the delta x to derive that formula, so it makes sense. So anyway, 3y squared also turns out that what makes sense actually turns out to be easy, so we like it when that happens. -2 to 2. Any questions about that? Find that integral for me in your calculator. We did the last one by hand. We'll just use our handy dandy calculator. Why is this integral slightly more complicated than the last one? Maybe more than slightly. Why is this one tougher? What did we do on the last one?
The other one simplified.
We could simplify it, and then what? We did a u substitution, and what was the derivative of the inside? Just a constant. And so constants are easy. Non-constants get a little more complicated. I think you'd need a trig substitution on this one. We'll do this one in our calculator. Okay, what do you get? Say that again.
17.261.
17.261. Okay. Any questions about arc length? A book page, not very many on the book page. Here, and I'm it does have some volume on it. So it goes back to volume and arc mixed together. So you have to remember volumes of solids as well. It says cylindrical shells at the top. You are welcome to use the shell method, but you are also welcome to use discs. I really don't care how you work them correctly.
So it
No, 1 through 5 is due on Thursday. AP 1 through 5 is due on Thursday. Good reminder. Oh, cool. AP 1 through 5 will be AP packets, Unit 8 AP packet. 1 through 5 will be due on Thursday. Tomorrow will be a work day. These two, we'll just grade these on Thursday also. I'll give you that work day on these as well, if you need it. However, I don't think our clip will take you too terribly long. We'll see. Maybe I'm wrong. And you have 20 minutes.